we talked about this slide the other day, that basically you have two groups of studies, descriptive and analytical. Descriptive, I think we talked about in detail the other day. Now, we also started looking at observational, and the observational studies, which are really the key represented the analytical studies. We talked about three different study designs: cross-sectional, cohort, and the case control. If you also remember very well, we said here that in all the studies, analysis depends on the accurate identification of what? The presence or absence of disease and the presence and absence of attribute. We further indicated that in all the studies, the analysis depends on what? On the analysis finally leads you to this 2x2 contingency table. You have disease present on and absent on the column, and then factor present or absent on the row or on the x-axis. So now the key here is the analysis finally comes to this 2x2 table. But we are talking about having different types of design. So this is really what you need to understand. If you look at the table, it's always 2x2 table. But we are talking about like 3 or even 4 different types of design. Now, the difference depends on what you do first. Are you first identifying the disease, or you are identifying the risk factor first? So this is one of the key differences. Starting with risk factor is different from starting with disease. This is one difference. The other difference is how do you sample your study population? Are you sampling them randomly, or you are just sampling them as they show up? So this is really the key. Otherwise, if you just look at the table, you really cannot see any difference, because in all the analysis for us is just coming down to these 2x2 table. But how initially the information or the data was collected makes the difference. So that is what I'm going to talk about. So the the difference or classification reflects 3 things. The first one is directionality. The directionality of the study. Directionality means, are you going from exposure to outcome, or you first ascertain the outcome, that is disease, and go back? So when we talk about forward directionality, you first ascertain what? Exposure status. Exposure is present or absent, and then after that, you ascertain whether the disease is present or absent. Again, this can be what? You may be looking at the record. It doesn't have to be you are first exposing and wait for the outcome. No, you can just look at the record. But always you start with what? Even if you are looking at the record, you start by first ascertaining the exposure, and then follow it up whether the disease develops or not. So this is what we call forward directionality. So cohort studies and clinical trials always follow this forward directionality. The other study design, the other design is backward directionality. In this case, what you do is what? You first ascertain the outcome. The disease is present or not, and then this is all the time it is what? Looking in the records, or maybe you administer questionnaire or interview. So you first ascertain the outcome, disease is present or absent, and then you look backward into any exposure. It does that what lead to this outcome. So case control studies always have this backward directionality. You go from the disease to the what? To the exposure. So that is what we call backward directionality. The third type is non-directional. That means you just go out there and try to ascertain both exposure and disease at the same time. So nothing comes first. You first ascertain with outcome and then immediately you record the exposure, or you first record the exposure and then the outcome. But the key here is what? You ascertain both at the same time. You ascertain both at the same time. So this is non-directional. So cross-sectional studies always follow this type of setup, where directionality is non-directional. So that is one way. The other criteria for classifying study designs is the sampling technique that we use. The other day in sampling, I showed you how we do randomization. So in experimental studies, we always what? We randomize the studies and then the investigator assigns the exposure status. So that is what we call, why we call it experimental. The investigator assigns the exposure status. So in clinical trials, for example, the investigator give one group a given treatment and then the other will receive a placebo. So that is what you call assigning. The exposure status is what? Assigned. So each group is what? Randomized to receive one exposure or the other. But in observational studies, other epidemiological studies, investigators simply does what? Observe as nature take its course, or observe yet exposure and outcome status. So the investigator is not intervening. So by just looking at what, whether randomization is there or not, you can have two different types of analytical studies, experimental or observational. In experimental, the investigator assigns the exposure status. Then the outcome comes out of that. In observational, investigators just observe the exposure and outcome status. So that is in terms of sampling technique. The third criteria is timing. This is somehow, it looks like directionality, but it is really a bit different from directionality. And timing means you are looking at what? The outcome status and then the study time. So by the time the study began, the outcome already occurred. So that is really what I mean by timing. So in prospective, if the time is prospective, what happens is that you decide what study that you conduct, that is the study begins here, and then in real time you have to wait for the outcome to occur. So by the time the study began, outcome has not occurred. So the investigator has to wait for the outcome to occur. So that's what we call prospective timing. So prospective cohort studies and clinical trials always follow this type of timing. So the health outcome already occurred before the study began. In this case, no. The study begins here, and then the outcome what? The investigator has to wait for the outcome to occur. So that takes time. That takes time. That's why it's called prospective studies. So prospective cohort and clinical trials always follow this type of timing. In retrospective timing, what happens is that, in terms of time, the exposure has already occurred, outcome has already occurred. So these have already occurred. So what investigator does is what? Start with the study here, and they look backward, look in the record. So he's not waiting for the outcome to occur, but the investigator just ascertain the outcome by looking in the record. So the setup in terms of directionality, it can still be forward directionality. In that case, what happens is what? Investigator starts his study here, and then look at whether exposure is present or absent by looking in the record, and also look at the health outcome by looking in the record. So although the directionality is forward, the data collection is what? Or the study is what? In terms of timing, it's retrospective, because when the study began, the health outcome has already occurred.
Are you saying looking for the recurrences of the same disease? Like, is this going to recur again?
Recurrence, recur. Recur means information or data. Record.
Record.
Oh, record. Oh, record.
Record,
Okay,
yeah.
thank you.
So you look at the record of the health state by starting from, you can start from exposure and then still go through what? Through the file and ascertain whether the health outcome has occurred or not. So the directionality is forward, but the timing is what? Is still retrospective, because you are not waiting for the outcome to occur, you are just ascertaining the outcome by looking in the record of, in the health record. So this is a table, just what I talked about. So based on that classification, we have these different types of studies. Experimental, as I said, the key here is what investigator manipulates which group receives the agent or treatment under study or exposure under study. In observational, investigator passively observe as nature takes its course. Then under observational, we have cross-sectional, which examines the relationship between exposure and disease at a single point in time. So this is what we mean non-directional, at a single point in time. So you ascertain both exposure and outcome at one point in time. In cohort, subjects are defined according to their exposure level and followed for disease occurrence. So you follow first to what? Group the population based on what? Exposure status. One group is exposed, the other is not exposed. And then you follow these two groups where the disease differentially occurs in them. So that's what we call cohort. Again, as I said initially, following can be what? In real time, or it can be looking in the records of what? Health information. In case control studies, subjects are defined as cases and controls. Cases means those with disease, and controls those without disease. And then what you are trying to ascertain is the exposure level in this group. So these are what we are going to look at, the cross-sectional, cohort, and case control studies. Any question?
Yeah, what did you say about cohort again?
I'll go over that
Thank
one more time in detail.
Awesome.
So let's talk about cross-sectional studies. In cross-sectional studies, what to do is to first identify your population as well, as a whole. So your study population. So this population composed of what? Subject with or without disease, and with or without the risk factor. So you don't know all of them. All you know is what? The general population. Then once you have your population in place, you classify the population based on what? Based on whether the disease is present or not, and the risk factor is present or not. So the timing is what? Really at the same time. So you don't know which one is occurring first. So what you do is what? You examine the relationship between disease and other variables of interest as they exist in a defined population at one particular time. So the classical example of this study is what they did in New York. They examined children, that is back in the early 1900s. So they examined school-age children, 6 to 7, for the cataract, and at the same time they collected blood to analyze the vitamin levels. So they checked the eye, the physician checked the cataract is present or not, and at the same time they collected blood. So everything occurred at the same time. So by that they established that those with cataract, children with cataract have severe vitamin A deficiency. So this is what we call non-directional. So as a result now, because you are collecting both information at the same time, and that means you are not also waiting for the diseases to occur, cross-sectional studies study what? Existing cases of disease in population. Existing means new and old. So all the new cases, as you know, have to measure all the new cases, existing cases, is prevalence. So that is prevalence. So cross-sectional studies measure prevalence. When we talk about prevalence, we just go out there and collect what? Old and newly cases. So that means existing cases. Because of the setup of the study, of this prevalence study or cross-sectional study, the major drawback is what? You really can't establish temporal sequence between what? Between exposure and outcome. It is very difficult to tell whether the exposure led to the outcome, especially when the exposure and the study is what? A changeable one. So if people can read the residence or people can cause some type of health behavior. So in that case, it's very difficult to say that a given exposure led to the outcome. Yep.
Are you saying that in the first slide, exposure and the outcome happened at the same time?
I'm not saying happening. You are ascertaining them at the same time. Let's say if you think that a given disease is sex dependent, you have your study population, male and female. All you have to do is go out there and then record the sex, which is female, and then try to ascertain whether the disease is present or not. It's just ascertaining or examining. Okay, let me put it. The same way you can talk about age. You can record the age of the age of the person. If the disease you think is age related, then you record the age, and at the same time you also record whether the disease is present or not. So you are collecting both information at the same time. So the drawback is really establishing what we call a temporal sequence, especially if the exposure and the study is a changeable one. One example that they usually cite in epidemiology books is, people with peptic ulcer. People with peptic ulcer usually drink milk. That means it's because of the burning sensation, they just try to cool it down to relieve that burning sensation. They drink milk. So if somebody go out there and collect the information where the person has peptic ulcer and also feeding habits, then you say peptic ulcer is present, at the same time record that he drinks milk. So in that case, it looks as if milk and peptic ulcer are associated, but the thing is, the persons with peptic ulcer usually drink milk to relieve that burning sensation. So in that case, this study cannot establish that temporal sequence, because of what? Because of the data collection procedure. As I said, the key is what? If the exposure is a changeable one. So these type of studies are usually good for permanent factors, so like race, breed, sex, and blood types, which normally do not change. Then in that case, whatever outcome, result received based on cross-sectional studies can be what can indicate the real situation. So in permanent factors, to study permanent factors, you can still use cross-sectional studies, but for factors that change, it is very difficult to establish that association.
Sorry, last time I swear. So is this basically the people who don't have the disease, are they being studied because they're at risk, basically?
No,
the ones that's being...
we talk about analytical studies.
Yeah.
Analytical studies, the key there, how we differentiated them from descriptive studies, that you really need a comparison group. Okay? They are compared to descriptive, you compare them. So you have people with disease and people without disease. You are trying to look at certain risk factors. So if that risk factor really differentially distributed in people with disease and people without disease. Or sometimes, the risk factor that you are looking at has nothing to do with the disease. As I said, for example, people with peptic ulcer drink milk because to relieve the pain, but healthy people don't drink milk. Okay, they may not necessarily drink milk. So in that case, what you are doing is what you are seeing, for example, people who drink milk, with peptic ulcer drink milk, you may think that those people are what? Or drinking milk leads to peptic ulcer. So in order to really see whether that association is real, you really need a comparison group. So always you look at comparison group. A comparison group means if you are looking at disease, you look at people without disease. If you are looking at a given risk factor, you also look at people without risk factor. So now, once you ascertain now the disease and outcome, now we go to our measure of association. So when we're talking about measure of association, we really always have to keep this in mind, comparison. So you have two groups all the time. If you are looking at disease, you have what? Disease group and non-disease group. You are looking at factor, risk factor. You have those with risk factor and those without risk factor. So one group is what? Always a group of interest, and the other group is what? That you think is what? Just carry an expected level of whatever you are measuring. So when we are talking about measure of association, we assess what? Relationship between factor and disease. Relationship between factor and disease with the two groups, exposure and disease. So, a relationship between exposure and disease among the two groups. Again, when we say among the two groups, it goes back to what we initially said. Most of the diseases that we have these days are what? They are multifactorial. So we really cannot say one cause is what. One factor is the cause of one disease. So there are multiple factors. So when we are looking at one factor, then all we can